Good afternoon. When someone else introduces me, I'm always lost for the first slide because I'm like, yeah, I'm Trisha, but you just said that. I'm a technical advocate for JetBrains, but you just said that. And my job is to, because I'm a technical advocate, one of the things I do is to stay ahead of the technical curve, figure out what's interesting, figure out what you guys are working on, what you're going to be working on, and hopefully help you with some of that stuff. So this is kind of a subject which is quite close to my heart. Like, how do we, as technical people, as developers, stay ahead of the technical curve, especially given how fast it's moving? Any JavaScript frameworks people? Yeah. Fortunately, I'm Java, so we only change every 2 years, and that's fine. So I kind of want to share with you some of my ideas around how we, as individuals, can stay ahead of the technical curve, and perhaps how we can help our teams do that as well. But what I really want you to take home from this is not how to stay on top of everything, every new technology that comes along, but the fact that adopting a new technology may not be absolutely the best thing that you want to do. Particularly, I'd like to learn, I don't know, Scala, so I'm going to implement something in production in Scala. That's a good way to learn. That's not a good way to learn. So, Java 8 came out last year, which, as I say, by JavaScript framework standards means it's been obsolete for 2 years. But what I want to show you is some of the new features of Java 8. Any Java people? A few of you admitting it, just, oh, it's Java, I'm sorry. Any Java 8 people? Oh, that's interesting, cool, that's good. But anyway, for the rest of you, I'm going to show you how we got lambdas, which you've had for ages, and we only just got. So I wanted to apply, this is kind of just a standard piece of Java code. I'm saving an order to a database. But what I want to do is Java 8 it. So I'm going to chuck some lambdas in here, because that's what you do. And lambdas should make things more readable, more succinct, more amazing, whatever. It doesn't matter so much about reading the specifics of the code. The important thing is that it looks like my code has an error condition, so a response to return on error, and a success condition. So to me, that says that maybe I can have an error handler and a success handler, and then I can refactor this whole thing into some sort of method that takes a lambda. Because remember, the goal of this exercise is to use lambdas. That's kind of the key point. So what I do is I refactor this method out, and I have a new save method, and it has 2 lambdas. I've got a success lambda and an error handler, which is fantastic, except for that's all of the rest of the code. So in order to start using lambdas, which are supposed to be more succinct, more readable, more easy to use, I've turned 30 lines of Java code into 44 lines of Java code. And people say that Java is a bit heavy on the boilerplate. No idea why. So that didn't really work out quite the way I wanted. I wanted to use new technology to make my code more readable, more maintainable, and I kind of made it more complicated. So let's look at another new feature of Java 8, again, just because I'm a Java person. So we have a new feature in Java 8, which is Java 8 Streams. This allows us to go parallel magically, which means our performance speeds up immediately without worrying about anything. This, by the way, is a lie. So what we want to do is we're going to use a magic incantation called parallel stream. I won't go into the code because it's not that interesting. The point is that if I'm doing a map operation where I iterate over 46,000 coffee shops in a list and turn it into just the coffee shop name, so a list of strings, when I do it in serial, it takes just under a second, whether it's on my MacBook or on my Surface. And when I go parallel, it takes about 0.6 seconds. So that's great. That did what it was supposed to do. I went parallel, and I got better performance, so my time taken dropped. So that's fine. So this means that I can magically, automatically get better performance, use more CPUs by using this magic parallel word. Of course, oh dear. If that was the case, then I wouldn't be giving this presentation. So there are cases where perhaps parallel is not the correct solution. So for example, I'm now doing a find any operation. So I've got 46,000 coffee shops. I want to find the first one with the name of Starbucks. I'm expecting there's probably one somewhere. So I'd use find any, and in serial, this will return to me in less than 20 milliseconds. So that's pretty quick. So if I run this in parallel over multiple CPUs, that should be even faster, right? No, it's about 5 times slower. Because the whole amount of work required to split up that data set, run it over multiple CPUs, recombine the results, is an expensive operation. So if all you're looking for is the first instance of something, there's no point in parallelizing that operation, probably. So the point about this is that your mileage may vary. So you can't necessarily adopt a new technology thinking, this is amazing, this will fix all my problems, this is my silver bullet, finally I get my silver bullet. So you have to stop and think about what it is that we're actually trying to achieve. So let's take a step back from, I'd like to lambdify this code because, lambdas are cool, and think about what it is that we're trying to achieve by adopting a new technology, a new process, a new technique, new and shiny. So this ties in quite nicely with something Dan said in his talk. As a developer, you're not just working in the context of just being a developer. You're working in the context of your wider team, of your organization, and so you have wider things to worry about. So we can think about there being three main reasons you might want to look at adopting a new technology or a new framework or a new process. Firstly, for the benefits of the business, for your organization. Secondly, for the benefits of your team. And thirdly, for your own benefit. So let's firstly look at the benefits for the business. So you have a business problem that can't currently be solved with your existing technologies, with your existing solutions. So you're going to pick you're trying to figure out which new technology, which new solution is going to solve this problem. So you might have a number of different problems. So I want some sort of customizable, real-time, flashy dashboard. Maybe I've got a new market opening, so my downtime is much less, so my releases need to be shorter, or so my reports need to run quicker. Or, for example, in this new big data world, our products might not fit into a nice database scheme, or our products might have not quite overlapping attributes. So how do we deal with those products, and how do we model them in our system? So just to go into one of those examples, because I used to work for MongoDB, so this is a MongoDB example. How many people have worked in a system where you had a relational database where a table looked like this, where you have more nulls than values? Right, that was our way of doing flexible schemas, right? You say, null, you can have null in there. And sometimes you have columns which are full of nulls. Some of them are kind of more populated. But it's quite difficult to get the benefits of a relational database when all you're doing is just flinging random bits of data into these tables. So when you've got problems like that, you want to identify possible technical solutions to those problems. So you might be looking at HTML5, JavaScript. I've been playing with JavaFX lately for a UI because actually, weirdly, you can still write UIs in Java. I had no idea. Because no one does that. You might be looking at DevOps tools. There's been some good talks today on things like Docker and so forth. So there are some great tools out there for helping you with deployments, make your deployments quicker, more repeatable. That might help you with some of your problems. And the example of NoSQL. So NoSQL might solve your problem where your data structure is not really that structured. How do you deal with unstructured data? So in the case of the NoSQL solution, the same data we just saw with all those null values, we can store that in something vaguely JSON-ish. Again, this is a MongoDB example. So in the first example, we have a coffee shop which has just got a location and a name. In the second example, we have a bit more information. And down at the bottom, there's an address and more information. But we can store all of those things in the same collection. So we get a bit more flexibility around how our data is stored, how we access it, how we query it. Now we've kind of figured out perhaps one or more technologies that might solve our particular problem. We have a number of different approaches to take. This is for solving a specific business problem. Notice that not one of those approaches is, put it in production and see how it goes. I have done that. It never works. So I've kind of ordered them vaguely in the order of lowest cost / effort to kind of highest cost and effort. So you can do things like spikes and prototypes. By the way, spikes and prototypes do not go into production, despite what we've all worked on in the past. So a spike should be a small set period of time with a specific set of questions to answer to let you know whether or not your technology may solve your problem. Prototypes are not just a short thing that you hack together over a week and then maintain over the next 2 years because people are using it. You can use the technology or the process or the tool in non-production code. So, for example, in your build process, maybe you have an information radiator for the status of your build, which you've built yourself. You might want to play around with some of the HTML5 stuff or JavaFX stuff there to see if that works. This has much less impact than trying to inflict a new technology on a customer when we're not even sure if that's the right solution. We can use it on internal fools, we have those too. Edit that from the video. We can use it on internal tools like administration tools for our own users who work inside the company. We can perhaps use a new technology on a new product, or if we're lucky enough to be working on microservices, maybe we can pick a small microservice and try out a new approach there. We can, of course, get the experts in, like, for example, any ThoughtWorks guys in? Yay. So, like, ThoughtWorks are great because so I used to work for ThoughtWorks too, I work for everyone. ThoughtWorks are great because they come in and they help you skill up your team in a particular tool or technology, and they're very experienced in these things, so they can kind of come in with their experience when perhaps your guys don't have that experience. Or you can bring in like a consultant or a contractor who has those skills. The important thing here, of course, is, especially if you're going to spend money on this sort of thing, is to get those guys to upskill your guys, because otherwise it's just a complete waste of time. So the whole point there is about knowledge sharing and learning. So, that's covering, perhaps you might want to select a new technology or process or whatever for solving a business problem. There might be, this is probably more likely in our domain, a problem that we want to solve for the team. So this is the sort of thing that never really quite gets prioritized on the backlog because there's no like burning business value for it, but it's your team is suffering from the pain of this. Let's say, for example, we have, like for example, releases being painful. The business never really cares that the releases are painful because, you know, you're the one who's coming in on a Saturday morning, spending all weekend doing the release, and they don't really care about that. But this is a problem that bites your team. For example, database schemas that, schema changes that perhaps we had use cases where a schema change could take days to apply, and that's just kind of crazy. Another thing that bites us again and again, I was very pleased to see the earlier talk about testing, is that testing is a difficult thing to do. Automated testing is a difficult thing to do right. So this can be very difficult, this can be inconsistent, we can have problems around the frameworks we use. And this is certainly a problem I had on one of the projects I worked on. You probably don't need to know JUnit to know that that's not a very good unit test. On account of the fact that 3/4 of the code of that is an assert statement. That's not right. We're doing a change, asserting something, doing another change, asserting something. And when you read a test like that, especially when it's got a really descriptive name like that, when you read a test like that, you don't really know what it is you're really testing, what the assertions are really checking. More importantly, when that fails, any one of those assertions could fail, and you don't know exactly what's failing and whether it's supposed to fail or not, what to do to fix it. Is it the test you're supposed to fix, or is it the production code? So, difficult to understand unit tests have quite a big impact on us as developers, but probably not going to get prioritized in the backlog as something we need to address immediately. So again, we do the same thing where we're going to identify possible technologies to fix our problems. So the examples I gave, we might want to look at something like Java 8 and Groovy for addressing the fact that we have a team full of people using different types of technologies. Maybe that kind of brings Java programmers a bit closer to other types of programmers. Again, DevOps tools and Docker and containers and so forth. NoSQL, because, you know, we mentioned NoSQL. And one of the solutions to our specific testing problem might be to adopt a new framework. Like we talked a little bit earlier on about frameworks up here, having test teams perhaps maintaining automated testing framework. There might be something that you can adopt as a team which makes your job a lot easier. For example, in that last team that we were looking at, we went for Spock. So Spock is a Groovy testing framework, and even though none of us actually knew Groovy, which is kind of could be challenging, it turned out that tests were much easier to write in Groovy. They were much easier to understand. Every single one of the assertions in here gets run, so if any one of them fails, we can still see the impact on the rest of the tests. We can still see if the other tests pass or fail. So this really fixed our specific pain point around tests. It was also kind of more fun to write Groovy, so we found that we were writing more tests using this particular framework. But what we did in order to come up with the fact that Groovy and Spock was going to solve our testing problem was we did a spike. We had a spike for a week. We figured out what our specific problems were around testing, what our pain points were. We tried Spock out on that, and we answered 6 specific questions around that. Does it fix our problems? And it turned out it did, and 2 years later, those guys are still using that. Again, you can use these things in non-production code to give them a go, see if it works, use in internal tools. There's kind of slightly fewer places you can play with new technologies in terms of trying to address problems for your own team, because you can't really inflict a new technology on the business just because you want to fix one of your own problems, because then you've got at least two problems. So perhaps you want to look at things which you can control, like internal tools. And of course, you've got things like skunkworks projects, hack days, 20% time, if you are kind of lucky enough to work in those sorts of environments. I'll talk a bit more about those later. The third reason you might want to upskill on technologies is, of course, for yourself. So I think that often, especially if you go to a conference and you see something really exciting technology-wise, and we've seen some cool stuff today, you do kind of get tempted to go home and play with this stuff and see how it feels. I would advise that perhaps you don't do that in your production code for your business, just so you can find out how Rust works, for example. But the reasons that you might want to play with a new technology are a little bit different to the reasons that you might want a new technology for the business. So, for example, you want to play with a new technology because you want to, reignite the spark of what being a developer is all about. Use some tools that perhaps you don't get a chance to use in your day job. Maybe you do want a new job, so maybe you want to upskill to move into a different role. Maybe you just want to be the expert in some technology in your particular job. Those are all kind of the joy motivators. There's also the fear motivator of, I don't want to be obsolete. I don't want Java to be the new COBOL so that I end up being unable to get a new job in 2 years' time. So I do want to be able to stay ahead of the technical curve. So again, we have a slightly different way of evaluating which technologies we're going to choose when we want to pick them for ourselves. We can basically pick any technology, process, or tool that we want to, because we're doing it for us. So you can have a look around and just basically see what looks awesome and fun and have a play with it. So for example, I'm going to give you an example of the fear motivator. So this is a good example of the sort of Java that we were learning at university. This is an AWT applet from the days when applets were the way forward in browsers. I'm showing my age now. So we learned AWT and we learned Java 1.1, and the millennium hadn't happened yet, and this was amazing. And then I found out about Swing. So in Java 1.2, we were going to get a new user interface, because even though we were only on Java 1.1, we already decided the user interface was rubbish. So Swing came along, and I decided, well, I don't want to be left behind. Like, I haven't even left university yet, so I need to upskill on this new technology. So I spent the whole of my third year at university sort of building this application in Swing. Clearly, I hadn't worked out how to use layouts yet. And I did this for my dad, and I inflicted it on my dad because he's a careers teacher, bless him, poor guy. And then I graduated university, and everyone was using JSPs, HTML, and JavaScript. So, no one uses Swing. I haven't used Swing in 15 years of professional development. So this is a total waste of time, other than learning that I don't know how to use layouts. Your approaches for figuring out what to do for yourself, to upskill yourself, are quite different as well. So if you want to stay ahead of the technical curve for your own personal reasons, you have to be prepared to invest some of your own time in this. And this is another thing which was covered earlier on about we have to be involved in the community. So things like going to user groups, I find that a really nice, lightweight way to figure out what's going on, take the pulse of the technical changes, figure out who's using what, figure out what the pros and cons of a particular approach are. So, for example, I might go to a user group, listen to an hour of talk about something like Docker, go to the pub afterwards, of course. Well, I can't drink right now, but normally I would go to the pub and have 3 or 4 or 6 drinks, find out who's using Docker, find out the pros and cons, and that's a really good way to sort of stay ahead of the curve without investing loads of time. Obviously, there's other ways of investing your time, so you can get involved in open source projects. There's loads of free online courses. Ultimately, if you want to, you could even get a new job which forces you to learn a new technology. I suggest that might be a little bit of a heavyweight approach to see if you like Scala, but, some people do that. Ultimately, if you're trying to learn a new technology for yourself, then only do it because you want to. Don't learn Swing because you think you should. Learn Docker because it looks interesting, or play with IoT and Arduino because that's kind of cool and you would like your coffee maker to talk to your curtains. So I'm kind of running out of time, so I'm going to get faster and faster. So what I want to do now is just follow up a little bit with how we've talked a bit about which problems we're trying to solve, how to choose a technology to address those problems, and how to take it from there. But we don't just have to look at a technology as soon as we desperately need it, because that's probably a bit beyond the last responsible moment. So as organizations, we can be a bit more proactive about investigating new technologies and upskilling our developers. Again, I kind of order this vaguely in order of like lowest effort to highest effort. So you can be running brown bags at work, you can have your own developers talking about the cool stuff they're working on, either in their own projects or in their own time, or like we had one guy who was converting an ant build to a Gradle build, so he spent a bit of time talking about why Gradle was amazing. You can even get people like evangelists like me to come in and talk to you at your brown bags if you like, because I get asked all the time to do like a Java 8 talk or an IntelliJ talk or something like that at some customer site, or even not even like a non-paying customer. So we'll come in and we'll talk to you about the cool stuff. User groups, user groups are, I'm going to do this as a promotion for having run our own user groups. User groups are always looking for venues to host stuff. As an organization, you can't say to your developers, you should go to a user group, it'd be really good for you, because that's not fair, because it happens in evenings and weekends. What you can do is you can say, why don't we open up our office for whichever user groups are interesting to us. We can host some Java event here or some DevOps event here, and we'll provide some pizza and stuff. That's fantastic for kind of encouraging your developers to fall from their desk into the user group. But it's also fantastic for recruitment as well, because people get to come to your offices and see that you're a company that's interested in making sure that your developers are up to skill. And who doesn't want that? Hack Day, Skunk Works, 20% time. These are mythical things that some people do. And obviously, you can send your developers to conferences like this, where it's a good way to get a feel again for the pulse and perhaps do a bit of training. So one of the most common complaints I hear is that if I invest all this time and effort and 20% time and conference money on upskilling my developers will up and leave. That might happen, but I can tell you one thing, that if you don't invest in letting your developers upskill themselves, if you don't invest in letting them learn and explore and develop, they will leave anyway. So you might as well invest that time, because then you can benefit from that. You then have developers who have higher levels of skills. They can figure out perhaps what are the right technology choices for a new project ahead of time, instead of scrabbling to keep up with some randomly chosen technology. Your developers might know the pros and cons of new technologies and processes and things ahead of time. Instead of like spending 2 weeks doing a prototype, it kind of does what we wanted. We're behind schedule anyway, chuck it into production. Never seen that happen either. Ultimately, of course, you have happy developers. And happy developers, not only do they stay with your company, but they say nice things about your company at the user groups they go to and online and in blogs and so forth. So as a developer, I think having happy developers is really important. I've got a flowchart here vaguely of the different approaches you can take for evaluating or trying out new technologies. This is available on my blog, so I don't really expect you to be able to read this. It's pretty, and Dan once said you should make like mind maps, so I did. I do what Dan tells me. So what can I do as an individual? As an individual, as a member of a team, as a member of an organization, we need to be identifying what problems we're trying to solve. What technologies might be good for solving those problems. We need to think about the why. But most importantly, don't panic about getting left behind. Don't panic about the 35,000 JavaScript frameworks that came out in the last 20 minutes. Just relax. Some things will come and go. For years, I didn't know Hibernate. I still don't know Hibernate. And for years, I was dead worried I'd never get hired because I don't know Hibernate. And all the job adverts say Hibernate. I've never had to use it. It's fine. It kind of went away. It's okay. Just pick the stuff that works for you, because otherwise you're just going to learn something and you're going to have a job in something that you learnt for the sake of learning that you don't like, and then you have a job doing the thing that you don't like. So just pick new technologies because you want to. Pick technologies which are going to solve problems that you have in the business or in the team, and try them out in fairly safe ways. Try not to punt them into production and then wonder why they went wrong. So find out why you're trying to what you're trying to achieve. Select and test the technology. Ask yourself the question, this is the missing step so often. Ask yourself the question, does this actually solve the problem we were trying to solve? And I know you just spent a week doing a spike or 3 months making a microservice in that technology, but it's still okay to say, no, this doesn't address the problem. Start again, go back to the beginning. You haven't wasted time because you've spent that time, you've invested that in learning. And that's what you take out of it, not lines of code, but the experience of learning with the pros and cons of that technology. And you might want to use that further on down the line. But if it's not right for this problem, throw it away, go back, and start again. Pick something else, try it out. If it is the right thing, then you can level up. Then you can start sending your developers on courses or conferences or whatever else is the next step in order to make sure that your guys are in the right place to solve the problems. So yes, okay, fine. So all the resources for this talk are here. There's a video of a slightly longer version of this talk at this link as well. The mind map that was invisible, that's up here. So yeah, that's me, thank you.